Okay, so on 4.5 here now. So we already talked about that we have two formulas that we're working with today, single deposit and periodic deposit. The single deposit formula we already used. Periodic is a new one to us. But again, all we're going to see is the difference in the phrasing for how you know which formula to use. Because once you pick the formula, you just plug into it. Yeah, the hard part is knowing the differencing in the phrasing. That tells you which formula to use. So that's what we're going to need to practice today. So the hard part with these questions is also a lot of times they're kind of long. So we got to really pick them apart and see which formula we need to use. So it says Rich and Laura are both 25 years old. They open an account at the Rhinebeck Savings Bank with the hope that it will gain enough interest by their retirement at the age of 65. They deposit $100 each month into an account that pays this much interest compounded monthly. What is the account balance when Rich and Laura retire? So once again, with these questions, if you see the word compounded somewhere in the question, guarantees you are going to be using, not this, there you are, possibly the percentage yield, so keep an eye out for that too. But these four are our compound interest formulas. Again, today's lesson, we're only working with these two. So once we have all of the formulas learned, we are going to have to know how to pick it apart and figure out which formulas we actually are going to be using. For right now, we know it's just going to be these two. And that is because, at least to start with, as it says here, the first question you're going to ask yourself in order to pick the formula is, what are we finding? What are we solving for? Both of these formulas are called find ending balance, find the ending balance. If we look back to our question, notice that this question says, what is the account balance? So this question by itself, what is the account balance, tells us that it will be a B equals. So that's why we know it's narrowed down to these two formulas, because both of these formulas do just that. They find the balance, and that's what we want. We want to find the balance. But we need to see what type of deposit it is. So this was step one. Again, we knew it was going to be one of these formulas because I told you those were the only two formulas we were looking at. But step two is now, is it a single or a periodic deposit? That's the difference between the two B equals formulas. One is for a single deposit and one is for a periodic. So here's what we need to do. We need to find the word deposit in the question and kind of read around it, read the sentence it is. So take a moment, see if you can find the word deposit in the paragraph and read right around it. See what it says. Well, right here it says they deposit. They deposit $100 each month into an account. They deposit $100 each month. That means they keep depositing it, right? Over and over again. So is this $100 then going to be a single one-time deposit or periodic? Does it keep happening? Periodic, right? The fact that it says each month. This tells us it's periodic. So we are going to be using a B equals for a periodic deposit. So looking to our formula sheet, that is this formula. B equals, we want the ending balance, but it is a periodic deposit. So we're going to copy this formula over. Now I happen to have it memorized, I think. It's been a while, but I should know this. We've got B equals P double parenthesis 1 plus R over N to the NT minus 1 all over R over N. I think this is right. Yes. Okay, so take a moment to copy that down. It's very important that you understand none of this is a typo. When you go to plug this in the calculator, you have to plug it in exactly as you see it. So these double parentheses here, again, are not typos. When you go to plug in the calculator, you're going to go whatever your P is and then double parentheses. You hit that button twice. Rule of thumb, it needs to look exactly as it's typed on the paper. But as always, we do want to lay out our variables so that we can write this out before we go to the calculator. P in this case still stands for your starting amount. The difference is here that you keep putting that amount in it doesn't matter. The formula does all of that math for you. So P is just your deposit amount. So what should P be here? How much are they putting into the account?
Will Heather Lee Peace Duran please report to the bus bay? Heather Lee Peace Duran please report to the bus bay.
They're putting $100 into the account. So that is P. Again, it doesn't matter that they keep doing it. It still is just 100 by itself. You're not going to have to figure out, well, how much have they put in? The calculator does that for you. Or I should say the formula does it for you. Go ahead and do your other variables if you haven't gotten them. I just want to kind of clarify that P is still 100. Even though they keep depositing it, it's still just 100. Go ahead and get your other variables. Okay, so R is 0.035. N comes from compounding. So find compounding if you got stuck. N equals 12. Compounding monthly, that means that'll happen 12 times in a year, right? Only because it says monthly is why it's 12. If it said daily, it wouldn't be 12, right? So we got to be careful. And T, here's what you're going to be careful about. It says, what is the balance when Rich and Laura retire? Well, neither of these is T, right? If they open the account at 25 years old and they want to have their money by 65, how many years is that total from 25 years to 65 years? It's 40, right? If I do 65 minus 25, that is going to be 40 years. So little trick there on the time. So you're going to use 40 for T. Because again, T is how long the account is open. They open it at 25, close it at 65. That's 40 years. So go ahead, take a moment. You're going to plug all of this in. Little hint here. The very first button you need to hit is the fraction button. Whenever you've got a huge, big, whopping formula like this that's got a top and a bottom, hit the fraction button. If you get stuck, you can come back and check, and I'll show you how we're doing it. Okay, so I'm going to write this out just so that I don't get anything jumbled up. I've got 100, double parenthesis, 1 plus 0.035 divided by 12 to the 12 times 40, right? This NT means N times T, so 12 times 40 minus 1 close parentheses. On the bottom, I have R over N, so 0.035 over N is 12. So this is going to look a little bit weird. We are going to kind of have a fraction within a fraction here, but it works. So I'm going to kind of go back and forth here. Okay, so the very first button I hit, because this is a big fraction, is the fraction button. If you do not hit that to start with, you're not going to be able to get the right answer. You're not going to be able to go back and fix it. So I'm going to plug this in very carefully. I've got 100 double parentheses 1 plus. I'll start with that. 100 double parentheses 1 plus, and then I've got 0.035 divided by 12 to the 12 times 40. 1 plus 0.035 divided by 12, close parentheses, to the, now because this is Desmos, I'm going to do this, I should have done this ahead of time, I forgot. 12 times 4 is 480. If you do 12 times 40, it's not going to let you do it in the whole exponent. You got to do that ahead of time. So I'm sorry, I forgot that. 12 times 40 is 480. And then I have minus 1, close parentheses. So as you can see, this looks like exactly what it shows on the paper for this formula. Yeah, I got the double parentheses. I'm closing my parenthesis off here. And I'm closing my parenthesis off at the end. Now at the bottom is R over N. So I'm gonna go to the bottom and hit the fraction button again. So I do have a fraction within a fraction. The math will still work out. Okay, this is what we got. 1,004,466. 100,004. Oh crap! I said that weird. No, I don't know what it is. 4,466. Okay. 0.69 this rounds off to. So what this is a lot of money, but this is pretty accurate. If you deposited $100 into this account, by the time they're 65, they're going to have this much money. Because again, they're doing this $100 over and over again every single month. So every single month, they keep adding money to it. So yes, by the end of 40 years, that's how much money they would have total. So once more, what we did for this problem was we figured out what formula to use based on the phrasing, right? We knew it was a B equals because I told you it was going to be a B equals, so at least there's that. But we figured out it was a periodic deposit. I should have written that. Because it said deposit each month. So it's very much so based on the phrasing. We got to be careful with this. Okay, so I want you to try this one. Again, what you need to do is read the question and determine which formula we are going to be using. So ask yourself the first question. Are we finding the ending balance or the deposit? What are they asking us to find? So I'm going to write that. Find ending balance, which is going to be a B equals formula. Or are they asking us to find the deposit? This is the first question you ask yourself when you are trying to figure out which formula to use. So read the question, figure out, are they asking us for the balance? Are they asking us for the deposit? Go ahead and read it. Okay, well, what they are asking us is how much will be in the account. That's literally what they're asking. This is a balance. How much is in the account is the balance. So we are going to use a B equals formula, which again is one of these two. The second thing you need to ask yourself is it a periodic or single deposit? So I'm going to write that. Periodic or single deposit. So I want you to go into the problem, find the word deposit, and specifically the word deposit. Shoot. Yes, the word deposit or something that means deposit. Hint, hint for this question. Read the sentence it's in. I just realized something. I'm curious. Okay, that's fine. Read the sentence it's in and figure out, is this a one-time deposit that makes it single? Or is this a periodic deposit? Does it keep happening? Do they keep depositing the money? So it doesn't say the word deposit, I'm sorry, but it does say something that means deposit. What do we think? Is this a single one-time deposit or does it keep happening? Here's the word that I was talking about. It does not say deposit, it does say invest. That does mean deposit in this case. They're putting money into an account. And here's the key thing. $250 per month. So this right here tells us it's periodic. So once again, this is going to be the same as before. It's going to be the same super big formula. Find the ending balance, a periodic deposit. Got 1 plus r over n to the nt minus 1, close parentheses, r over n. So take a moment, write your variables out. I'll scroll back up so you can see it. Plug it in, see if you can get the right answer. Again, like I said, it's super easy to make mistakes on this formula. Very careful how you plug it in. Okay, so P is 250. P is what we're depositing. R is 0.042. N comes from compounding, and it is compounded monthly. So that means that N equals 12. How many times in a year? Well, if it's monthly, it's 12 times. And in this case, it's just 20 years. So they tell us we didn't have to figure that out or anything like that. Okay, so I am going to go ahead and start plugging this in here. I'm going to clear this out. I'm going to hit the fraction button first. I've got 250, double parentheses, 1 plus 0.042 divided by 12. Close parentheses, to the 12 times 20. That was NT. Whoops, again, here's my mistake. I forgot again because when I have these calculators, I don't have to do this ahead of time. But I do need to know what 12 times 20 is. 240. Okay, so my exponent here is 240 because that was 12 times 20. And then I have minus 1, close parenthesis. At the top of my fraction. Bottom of my fraction is r over n, not exponent. What was I doing there? Ah, crap. Dang it. Okay, I'm going to backtrack. I mess this up anyways. Okay, so I am going to write this all out. It is kind of a pain in the butt. But again, guys, there's so many ways you can make mistakes if you don't write it out originally. 12 times 20 minus 1, all over 0.042 over 12. Now, again, because I'm using Desmos right now, I need to do this. 12 times 20 is 240. So I do need to do that if I'm using Desmos. So going back to Desmos, I got my fraction button all ready to go. 250. 1 plus 0.042 divided by 12 to the 240. Again, I already did that ahead of time. Minus 1, close parenthesis. And then fraction within a fraction, 0.042 divided by 12. Whoops. I forgot that I already did that. There you go. Okay, so you should have gotten 93,783. 783.74. Yeah. Again, because this is a periodic deposit, we keep putting money in the account. That 250 goes in every single month. So we're going to have a lot of money by the end of 20 years. Not only do we have all the money that we put in, but we also have all the interest that we've gained. So one more time, all I want you to do for this question, you're not actually going to solve it. If you would like to, you can solve it. But I want you to figure out, circle the keywords or phrases in the question that tell you what formula to use. So if you don't have the notes packet, just kind of keep it in your head. Or you can write the question down or whatever. There was 2 questions you ask yourself. Are you asked to find the ending balance or the deposit? So circle the words in the question that tell you, are we finding the ending balance or are we finding the deposit? And then circle the words in the question that tell you if it's a periodic or a single deposit. So see if you can do those 2 things. Again, circle which words tell you that we are finding the ending balance or finding the deposit. Which words tell you the answer to this question? And then which words tell you the answer to this question? Periodic or single deposit? Go ahead and read. See if you can figure out what words are telling you the answers to these questions. Okay, so right here, how much money will be in the account? That's the answer to this question. Find the ending balance. Because they say how much money will be in the account, we want to know the ending balance. So that tells us it's going to be a B equals formula. Then, to figure out if it's a periodic or single deposit, we go blah, 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 hey, deposit. I'm going to read around it. It says 300 monthly deposit. So this tells me it is a periodic deposit. So it's a B equals find ending balance for a periodic deposit. This and this tell me what formula I'm using. It's okay if this is a little bit confusing right now. Like I said, one of our lessons is just going to be attacking this. How do I choose the correct formula? If you didn't guess it, for this lesson, it is only this one formula. So in your homework, it literally is just practicing plugging into this again because this formula is a little complicated, as well as some review problems. So keep an eye out for that. We have 2 more formulas we're going to learn. And then lesson 4.7 is about choosing the correct formula. So we'll delve into that a bit more in that lesson.